Assalamu alaikum, dear students. I hope that everyone is doing well. Welcome to the second session of the week, Unit 4, Partial Fractions. For today, the topic is resolution of fraction into partial fractions when denominator consists of known, repeated, irreducible quadratic factors. Dear students, before proceeding towards the topic, let's have a brief revision of the previous topic, resolution of fractions when denominator consists of repeated linear factors. In the previous lesson, we learned how to resolve the resultant fraction into partial fractions when denominator consists of repeated linear factors. Here we can see that x minus 1 is linear and it is in repetition as square is above it. So the partial fraction of this fraction can be made as a divided by x minus 1 plus b divided by x minus 1 whole square and plus c divided by x minus 2. So if it is in repetition, so in the second fraction we can write square upon 8. This is verified below here that x minus 1 is with square, so it can be written 2 times. When we solve it ahead by taking the LCM, so as LCM is the product of common and non-common factors, x minus 1 is the common factor, whereas x minus 1 and x minus 2 are the non-common factors. X minus 1 and x minus 1 can be written as x minus 1 whole square here. So here we can see that by making the partial fraction like this, we will get the same denominator. We will get the denominator of the resultant fraction back. If you will not write square above 8, so you will not get this denominator back. So if you have this type of resultant or single fraction, so the partial fraction will be made like this. Here we have exercise 4.2. Let's revise question number 7 here. Okay, we are going to resolve this single fraction into partial fractions, but before making the partial fractions of it or the components of it, you must see that whether the fraction is proper or improper fraction. As we know that the single fraction or the resultant fraction is always in its simplified form. So if it is not in its simplified form, so we must simplify it by division or by converting this into proper fraction. As we know that the degree of polynomial in the numerator is 2 and degree of the polynomial in the denominator is also 2. So it means that division is possible here as both of these are equal, so it can be divided and it can be converted into proper fractions. So let's do it by long division here. Numerator is written inside, whereas the denominator is written outside as divisor. Here we can see that inside 3 is written and here the coefficient is 1. So x squared should be multiplied with 3 in order to get 3x squared. So 3x squared, 3 4s are 12 and 4 3s are 12. By subtraction we will get 15 minus 12 3x and 16 minus 12 4. Here we can see that the degree of the remainder is 1 and the degree of the divisor is 2. So 1 is less than 2, it means that this is converted into a proper fraction. So let's write it here. 3 as a whole will come 3x plus 4 is the numerator, whereas this is the we can see that the denominator here. Okay, this is basically the shrink form of x squared plus 4x plus 4. When we have to make the partial fraction, so it must be in the shrink form. So let's make the partial fraction of the remainder now. For now you are going to ignore 3. At the end we are going to write it then. When we are supposed to make the partial fraction of these, so it will be a divided by x plus 2, and since it is in repetition, so in the next fraction it will come with this square. Now in order to find the values of this constant a and b, we are going to multiply this equation with the LCM in order to eliminate the fraction. So the LCM will be of course this one, x plus 2 raised to the power 2, because when you will take the LCM of these two fraction you will get these. So we have to multiply this with the LCM x plus 2 whole square. When you will multiply, so you can see that what will get cancelled, this one will get cancelled and the denominator of b will also get cancelled, and with a you will just having 1 time x plus 2. So let's go ahead, then you will see here 3x plus 4, and with b there will be no any expression. Okay, this will be named as equation number 1 here. Okay, this equation is used for putting the value of x in order to find the one of the constants here. And this means equation can be further expanded, like bracket can be eliminated, a with x and 2a. This equation is used for equating the coefficient. Okay, now first of all we have to put the value of x at how many value of x we have here. We have just one value of x, as the value of x can be just -2. So by putting x is equal to -2, we can find just the value of b. So how we have to find the value of a? It can be done with the help of equating the coefficients, which will be elaborated ahead then. Okay, put x is equal to -2 in equation. So instead of x, we are going to put -2 here. So you can see here that a will get 0 because -2 plus 2 will be 0. So a0 is 0 and you will get the value of b as -2 here. Now, in order to find the value of a, we are supposed to, or we are compelled to equate the coefficients because we don't have any other value of x. Since we know that this is equation of identity, as this equation is derived from this one. This is equation of identity because this is the whole and this is the part, and the parts make the whole. So both of these sides are same. So therefore, this will also be same. So whatever will be, if it is 3x here, so here also should be 3x. So the value of a should be here 3. Fine. So therefore, you can from the equation of identity, by equating the coefficient method, you can find the unknown values. Either you can equate the coefficient of x, or either you can equate the constant terms, up to you. So let's equate the coefficient of x here. So you can see here that x exists. This is x and this is x. So what is the coefficient of x here? 3. Then equal sign, and the coefficient of x here is 1. So the value of a will be what? 3 here. You can see this is the value of a. This is done by equating the coefficient. This is x square. It is x, not x square. Okay, now these are the required partial fractions, and you are not going to ignore these 3. Should be added at the end. Okay, here we have today's topic, resolution of fraction when denominator consists of non-repeated irreducible quadratic factors. In today's topic, we will have such type of fractions in which the denominator will be non-repeated. It will not be in repetition. Moreover, it will be irreducible quadratic factors. Here you can see that we have quadratic factor as well as linear factors. In the exercise 4.1 and 4.2, we had the linear factors. Moreover, we had the quadratic factors, but those quadratic factors were reducible to linear form. But in exercise 4.3, we have such type of quadratic factors which cannot be factorized or which cannot be reduced to linear form. Like you can see x square plus 9. Neither we can take a common here, nor it can be factorized by application of formula. So therefore, it is irreducible. So let's learn today that how we can make the partial fraction of this type of fraction. So here we can a, since it is the linear factor, so here will be just the constant a, but here we have the denominator as quadratic, so therefore the numerator here will be the linear. Let me tell you here that if the denominator is linear, so in numerator there will come 1 degree less. Like if x is raised to the power 1, so less than 1 is what? X raised to the power 0. Okay, so means less than 1 is then constant term here. Fine. So we can just here let a, and less than quadratic is what? Linear. So therefore here we are going to write the coefficient of this linear term as b, the constant, or the coefficient on x is raised to the power 1, then we have to write the constant term. I am again repeating that if the denominator is linear, so here we are just going to write the constant a. If the denominator is quadratic, so in numerator there will come the linear expression then bx plus c. If you will just write here b, so you will not get this resultant fraction back. So it must be written bx plus c. This is proved. Here we have now exercise 4.3, and the question is that we are going to resolve this into partial fractions. We have question number 1 here. Okay, here we can see, first of all, we have to see that whether it is improper or proper fraction, since the degree of polynomial is 1 here and it's cube, x squared with x will be cube, so it is of course proper fraction, so no division is required here. We are going to make the partial fractions in the very first step. Okay, here we can see that x plus 3 is the linear, so therefore the just in numerator we have a, and the next factor is quadratic, so therefore we are going to write in the numerator bx plus c, the linear expression there. Okay, now the same procedure will be applied that in order to find these unknown values, we have to multiply both sides by the LCM. LCM will be x plus 3 and x squared plus 1. So this one will get cancelled and we will just have 3x minus 11. Okay, with x, this one will get cancelled, and with a we will have just ax squared plus 1. Then bx plus c, you must put bracket with bx plus c so that x plus 3 can be multiplied with both of these, means bx plus c. So the denominator of this will get cancelled and we will just have x plus 3 with bx plus c. Okay, this can be named as equation number 1, as this equation is used for putting the value of x. And the next equation will be the expanded form of this equation, and this can be used for equating the coefficients. Here now we have 3 unknown values a, b and c, so we are supposed to find it. Let's see that how many value of x we can derive. We can derive just one value of x, as x will be equal to minus 3. So one unknown value can be found out with the help of putting the value. Okay, why we cannot derive the value of x from the quadratic factors is justified here. You can see here, if we just try to find the value of x from these quadratic factors, so what will be the result then? Here x squared, when 1 will be shifted to that side, we will get minus 1 here, and you can see here, in order to find the value of x, we can take square on both sides, and now you can see that 1, the square root of 1 will be 1, and since the square root of minus does not exist, so the square root of minus is imagined as iota imaginary. So here we are not going to use the value of x as imaginary, so therefore we cannot derive the value of x from the quadratic factors. So in order to find the other unknown values, we are compelled to go with the equating coefficients method. So let's go ahead. Here, of course, just multiplication is done. You can do it yourself. Bx is multiplied with x plus 3 and c is also multiplied with x plus 3. Cx plus 3c, you can see. In the third step here, we have gone with the arrangement, means x square terms are written first, then linear terms are written, then the constant a plus 3c are written. This is just done for the sake of convenience ahead for equating the coefficients. So let's put the value of x is equal to minus 3, and we will get the value of a here, because if you will put minus 3 here, so this bracket will get 0. When 0 will be multiplied with this whole bracket, so you can get, you will have 0. So you can do this directly. You can put 0 and you can just find the value of x squared here. You see that this got 0. No need to write, and 3 3s are 9 here, and here also instead of, you can see here we have x, so instead of x we have put minus 3. 3 3s are 9, and by calculation we will get the value of a is minus 2. 10 is being multiplied at their sides, we will get divided by 20, so 10 1 is 10, 10 2s are 20. This is the value of a. Now we don't have any other value of x, so we can find the values of these two unknown values b and c by equating the coefficients. So let's see that b exists with what and c exists where. Let's go with this. Here this is going to be used for equating the coefficient. Now we are going to find the value of b. So b exists here, means you can equate the coefficient of x square. So one more x square exists here with a, and here we don't have any x square, so here we can put 0 at this side of the equation. Moreover, if you want to have the value of c, so c exists with what? You can see that c exists with constant as well. Up to you whether you want to take the constant or whether you want to take the coefficient of x. Up to you which one is easy for you. So we can take the constant here, that a is also constant, 3c is also constant, and here minus 11 is the constant term. So we can make these two equations here. To find b and c, equating coefficient of x square and constant. So what we get, a plus b is equal to 0. Here you can see a plus b, and there is no any x square, so 0. And next equation will be a plus 3c is equal to, here you can see a plus 3c is equal to minus 11. So we can find the value of b here. A is equal to minus 2. Instead of a, we can put the value minus 2 here. So the value of b can be found out. B is equal to 2. And the value of, here you can put the value of a minus 2, and the value of c can be found out. This is minus 3. We can put this in the equation. So the value of a will be minus 2. The value of, this is b, x plus c, b. The value of b is 2. X is written from here, you can see. This is x. So b with x, then plus c should be written. So the value of c is what? Minus 3. So plus minus minus, so these are the required partial fraction. If you add these both partial fraction, if you solve it again, so you will get these as the answer. So you can verify it yourself. Now we have question number 2 here. It will be done in the same way. Here you can see that the quadratic term is written first. So you can write it as the denominator is the quadratic. So here will be ax plus b. So in numerator we must have the linear expression, and the next denominator is linear, so there will be just constant then. Fine. Again the same procedure, that multiplying both sides by the LCM, we will get here 3x plus 7. With x plus b we will get this, and with c we will get x square plus 1. By expansion we will get equation number 2. Now we can put the value of x, what? Minus 3. When we'll put x is equal to minus 3, so this will get 0, and we can find the value of c, because minus 3 plus 3 will get 0, and this whole will get 0. And value of a and b can be found out by the equating the coefficients. Here you can see that now I'm going to tell you that we can equate the coefficient of x square. So here we can have x square. Let me highlight it for you. This is x square. Okay, excuse me. Okay. This is x square, this is x square, and if you don't have any x square here, so you can write 0 as 0 x square exists. Okay, let's go ahead. By first of all, let's put the value of x minus 3. Then we can see that what we got here, we can have the value of c by putting x is equal to minus 3, and the value of c will be minus 1 upon 5. You can do the calculation by yourself. As I told you that this whole expression will get 0 here. And okay, there is no any plus sign. Let me rectify this mistake. There is multiplication sign. This is okay. So this will get 0, and 9 plus 1 will be 10. 10c is equal to minus 2. So 10 will be divided to that side of the equation, and the value of c will be minus upon 5. Now we have to equate the coefficient of x square and constant. Up to you whether you have to equate the coefficient of x square or x or constant. In order to find, you will get the same answer. So coefficient of x square will be a plus c is equal to 0. A constant term are 3b plus c, and here we have the constant term as 7. So these two equations we will get. A plus c is equal to 0. The value of c is minus 1 upon 5. It is put here, and we have found the value of a. Now we have the next equation, which is the constant term here, and we have put the value of c, and then you can see here that minus 1 is shifted to that side of the equation, plus 1 upon 5. Here we have taken the LCM. 7 5s are 35. 35 plus 1, 36 here. 3 is being multiplied at their side, it will get divided here. 5 3, okay, 3 1 is 3, 3 1 is 3, 3 2s are 16, sorry, 3 1 is 3, 3 1 is 3, 3 2s are 6. So 12 upon 5 will be the value of b here. Then we can put this in the required partial fraction. This is the value of a, 1 upon 5. This is the value of b, 12 upon 5, and this is the value of c, minus 1 upon 5. Here you can see that 5 is in denominator, so you can write it 1 as by means 1 time. That will be okay here. And then here 1 upon 5, it means this is like this. Let me tell you here. This is like, suppose 1 upon 5 is written, then x is left plus 12, and 5 is written in denominator. Fine, like minus plus minus minus is written here, then 1 and 5 is written in denominator. You can leave your answer in this form as well, doesn't matter. Now we have question number 5 here. Okay, excuse me. We have question number 5 here, and it will be done in the very same way that you can take, since it is quadratic in denominator, so you have in numerator you have suppose linear factors bx plus c multiplying both sides by the LCM. Here we will get the same, we can say that okay, the same procedure are done. This is being expanded here. Okay, let's go ahead now. Now we can see again that we can put the value of x is equal to -3, and then we will get the value of a, and b and c can be found out by equating the coefficients here. So when we'll put the value of b, so this whole expression will get 0, 9 plus 4 13, and the value of a will be -2 upon 13 here. Now to find b and c, we have to equate the coefficient of x square and constant here. Let's see that how many equations can be made by equating the coefficient. Let me again voice it for you. Okay, a coefficient of this one x square will be this one, and here we will get 0. So a plus b is equal to 0, whereas constant term are 4a plus 3c, and here we have constant term as 7. So a plus b is equal to 0, 4a plus 3c will be equal to 7 will be the two equations. Yes, you can see here. Now the value of a is put -2 upon 13, so then the value of b can be found out. Next equation is 4a plus 3c. The value of c is a is put, then we can find the value of c here. Okay, 4 2s are 8 divided by 13 plus 3c, then 7 is here. Okay, 3c minus 8 upon 13. We can shift to that side of the equation with the constant term. It will be with positive sign. Now we can take the LCM here. 13 will be the LCM. 13 7s are okay, 7 3s are 21, then 21 7 91, 91 plus 8 will be 99, and 3 is being multiplied. It will get divided to that side of the equation. By simplification we will get this as 3 1 is 3, 3 3s are 9, and 3 3s are 9. So the value of c will be 33 upon 13. Okay, here we can put this is the value of a, this is b, and this is c. You can write 13 in the denominator here. Now again 2 should be with x, and it's like 2 upon we can say that it is b, 2x upon 13. Let me write it for you. It is like this basically, 2x divided by 13. Fine. So we can write 2x here, and 13 can be written in denominator. Since 13 is being repeated, so we can write is this x is with 2 here. So 13 will be written one time, and this is not 336, this is just 33. Okay. Now we have question number 8, and it is going to be done in the very same way. Here you can see that it's of course a proper fraction, but here a hint is also given in your book. But if hint is not given, you must see that if the denominator is able to be factorized. I told you earlier as well that if the denominator can be factorized, we have to factorize it. See, you can see that it's cube, so we can apply the formula of a cube plus b cube here. So here you can see that this a plus b, then a square minus ab plus b square, the formula is expanded here. Fine. So you must apply the formula here, as factorization is a part of this, that the denominator must be factorized, then we can make the partial fraction here. Okay, we can write this, and the first fraction will be with linear, whereas the second fraction will be with the quadratic denominator. So therefore the numerator is written as bx plus c. So the LCM will be the same. We will multiply it with the LCM, and we will get this as it is. With a we will get this factor, whereas with bx plus c we will get x plus 1. Then we have to expand this, and we have to multiply a with this whole bracket, and bx plus c should be multiplied with x plus 1. So bx square, bx with 1, bx, cx, and c1 is c. Okay, next we have to arrange this. Quadratic terms are written first, then linear, then constant terms. This equation is going to be used for equating the coefficients. Now, how many value of x can be derived? Only one value of x, which is -1. We can put this in the equation and we can find the value of a from it. You can see that all these you can put it directly. If you run short of time, this will get 0. Hold this expression 1 minus 1 0, so 0 and multiplied with this whole, it will be 0. You can directly put 0 here and you can find the value of a. Instead of a, we have to put 1, then again 1 and 1. You can see here 1 1 and 1, so it will be 3a, and the value of a will be 2 upon 3. Okay, now next is going to be used for equating the coefficient. Now we can see that how we can equate the coefficient. Coefficient of x squares are a and b, and here we have x squared. What's the coefficient of x squared there? 1. So a plus b is equal to 1. You can see here a plus b is equal to 1 will be the first equation. Instead of a, we are going to put the value 2 upon 3, and here you can see that LCM is taken here. 3 is the LCM. 3 1 is 3. 3 minus 2 is equal to 1 upon 3. You can solve it with the help of calculator if you don't like to go with the LCM. And the next equation can be, if you want to equate the constant, here we are going to equate the constant. So let's see the constant. What are the constant here? A plus c. Constant are those with which x is not written. So here the constant is 1. A plus c is equal to 1 will be the next one. So we have put the values, and again LCM is taken here. So we'll get 1 upon 3, the value of c here. This is the value of a. The value of b is what? 1 upon 3, you can see. And the value of c is also 1 upon 3. 3 is the common denominator. It is written one time, and then x square minus 1 is written. So in the numerator, this x should be written above. So x plus 1 will be the numerator here. Okay, here we are done with exercise 4.3. Hope your concepts are clear and you got the concept. Here is your assignment for today. You are going to do exercise 4.3 in your neat notebook. This is all for today. Have a nice time and stay blessed. Thank you so much.